Yes. All right, you're all set.
All right, can people hear me okay? Yep. All right, cool. So I'm just going to be briefly going over some of the different authentication methods that Windows uses and different attacks that you can do on those methods. So that's me. I'm a first year CSEC BSMS student. Right now I'm looking towards like forensics and incident response type stuff, but I do a bit of everything. CTFs are cool. If you don't do them already, do them. Join Contagion. I like robotics and drawing, and I also like cats and dogs because animals are great. Some general Windows terms. Active Directory is kind of enterprise Windows, a bunch of Windows computers connected together, and there's some interesting attacks that can kind of span Active Directory, and that's a whole separate topic. SAM, that's a kind of keyword. It's a file that stores a lot of the Windows passwords, and if you can dump that file, you can do interesting things with those hashes. And the LSA is kind of the application that handles all of the local authentication. And there's a common tool, Mimikatz, that's used to, did I pronounce wrong? That can dump memory from that to get Windows hashes as well. So different hash types. So when Windows stores passwords, it obviously doesn't store them in plain text. It stores them as in their hashed format in the SAM file. So there's a really old version called the LM hash. It is very ineffective as a hash. It's very easy to crack with common tools like Hashcat or John the Ripper. It's kept around sometimes in old systems and in companies for legacy reasons, because if it's disabled, then it can break things. Every effort should always be made to disable that and get out of that legacy, because if you can get an LM hash, you can probably get the password. And the NT hash is the current way of hashing passwords. It's a little bit better. It doesn't get split into these 7-character chunks that are really easy to brute force, but it's still pretty crackable with some common tools. So this is kind of the first attack. I'm not going to be going into technical details on these, but just some general information. So essentially the way that NTLM authentication works is, instead of actually looking at the user password itself, it only checks the hash. So if you have the NT hash, you don't actually need the password for a lot of things. And if you can just kind of bypass the password step and give it the hash instead, you can authenticate like that. And Windows does a thing called single sign-on, where you have one set of credentials to access a lot of different resources and systems. So if you can do this, and you can access a lot of those systems with just one set of a username and hash. So the NTLM protocol itself is actually entirely different from NT hashes and LM hashes. It's the actual protocol. Windows loves their acronyms, and it gets very much like alphabet soup. So that's something to keep in mind with Windows. But V1, it's cryptographically reversible to NT hash. So if you can see these communication channels, what the client does is the client sends a message to the server saying, hey, can I log in? And the client sends back, okay, well, you have to prove that, so here's a challenge. And the user has to send back that challenge encrypted with the hash of their password. And then if the server takes that and that's correct, then they get access. So for version 1, you can actually intercept some of these traffics and basically extract the NT hash from these communications, and then you can crack that hash using things like Hashcat. And it's also vulnerable to SMB Relay Attacks, which I'm going to talk about on the next slide. Version 2 is better. The challenge is more complicated. It's variable length, harder to predict, and harder to reverse. And it also makes it more difficult to do relay attacks using timestamps and some more restrictions on the timing of it. So the SMB relay attack essentially compromises the link between the client and the server, so that the attacker can end up impersonating the client. So what it does is, essentially in the network, the attacker kind of positions themselves in between the client and the server, so that then they can kind of forward the messages between them. So when the client gets authenticated, instead of the client sending the challenge back and then getting authenticated, the attacker forwards that challenge, and then the attacker ends up getting authenticated. And this is done. The reason that this can happen is because there's no mutual authentication with the server itself, so there's no way for the client to ensure that the person that it's communicating with is the server. So you can get access this way. There we go. So this is also a fun one. Link local multicast network, or link local multicast name resolution. Yeah, alphabet soup. And NetBIOS name service. And so normally the way that host name resolution works is it goes through DNS, right? But if that fails, so in this diagram there, they're trying to connect to Pint server, which is not a print server, but that's what they're trying to connect to. And the way that Windows handles these kinds of errors is it has this service, and what that does is it asks other computers on the network, hey, do you know what this service is? Because DNS doesn't. And if you intercept this kind of error, the attacker can go and say, oh yeah, that's me, I'm a Pint server. And then the client will connect to the attacker and essentially send their credentials straight to the attacker, which then the attacker can use for things like remote code execution. So that's another fun way to do it. So this is Kerberos. It's a newer authentication method. And essentially, what Kerberos does is when the client wants to attack to a server, it has to go through a third-party application. This is kind of the current good default for Windows right now, because it's a lot harder to intercept. So as you can see in that diagram, the client is generating that ticket and then using the ticket from the third party to authenticate to the server. So there's a couple of different attacks that you can use with something like Kerberos. You can use Kerberosing to intercept these tickets and try to reverse them to get passwords. You can use overpass the hash, which is very similar to pass the hash itself, but it's using an NTLM hash to request the tickets. And then you have pass the ticket, which is quite literally pass the hash, but with tickets. It works the same way, essentially. And you can also do something with Mimikatz using called forging, where if you have the correct permissions, you can fake having tickets and use those fake tickets to authenticate. And that can get very, very powerful. The golden ticket, for example, which is very difficult to get access to forge already. But if you do, then you can access any computer in the domain, which is very powerful. Many links. Questions? Cool.
Okay. I'll just stay up here a little bit, Alec. So since this is Alec's first presentation, he'll be receiving the RIT-Sec lanyard. Let's go! Awesome presentation, Alec. That was amazing,